Hello, Algebra 1 students, for Mr. Fry on February 8th. We're looking at this. I'm not sure if you got this today or you're going to get it in the near future, but I know you were talking about this today. You may have done some of these in class also, as I've been in and out of other classes. So I'm going to take you through a few of these. Number one, the following numbers are percentages on a recent math test for a class in the high school. Fill in the frequency table listed below with the given intervals and then create an accurate histogram of the data. So what I did here is I just went through, and my slash marks are me figuring out, the 51 through 61 grades, and do my tally marks, and I would mark them off and just going through. It's just really tough. There's 33 grades here, 33 of them I counted, and it's a lot to go through and keep straight. So these are my tallies, my frequency that I got. And then my cumulative frequency, should add up to 33, and it did, so I didn't miss any. So it's good to keep track of that cumulative frequency. So hopefully you're pausing this. And then later on, in order to figure out some of the questions on the back of this page or in the next page, you had to put them in order. So I put them in order to figure out if I was getting them all. I had circled them. This is my way of just keeping track of the ones that I already used. And it's pretty hard on the eyes, keeping track of all these numbers and all that. There are calculators online that you could just enter these and they'll order them for you and figure this stuff out, and that makes life a lot easier. The frequency and interval, the histogram, in other words, is going to look like this. Don't mind that little line that went astray. But so the scores between 51 and 61, there's three of them. 62 to 73, 72 would be 10, and then 73 to 83 would be 10 more, and then 84 to 94 was 6, and then you see 95 to 105 is going to be 4. So you just kind of graph that like that. Okay, moving on, just for number 2, the percentage range was the most common, 62, 83. I started to answer these, and I was like, no, you guys can answer those questions by that data. Number 3, now we're working with mode, median, mean, and range. And I always start with mode because that's the easiest, the most repeated, and you're going to have to pause this and write these down if you didn't have them down already. The median is the middle in the listing from least to greatest, and that happened to be 77. 89 was the most repeated, by the way. The mean, you add all the entries or all the data together, and then you divide by how many entries there were. So when I added them all together, which took a long time, and on your graphing calculator, it makes it easier because you can see it all printed out. I tried it on a regular calculator and it wouldn't take all that information, so the graphing calculator was the best. Divide it by 33 because there's 33 entries that you put in there, and it becomes 76.79 something. So it's approximately, a little squiggly, equals 77. And then the range is always the largest to the smallest, or the greatest minus the least. So the largest minus the smallest, I should say, or the greatest minus the least. So that was 100 minus 51, so your range is 49. Try 4 on your own. 5, you can use a box and whisker plot calculator online. That's very helpful, and you just enter this data, knowing that this is 25% of the scores, this is 25%, this is 25%, this is the median, and this is 25% of the scores. It just breaks them up into 25 percentages, so you can kind of have a better visual of the spread of these scores. For number 7, some examples, and you could use your own examples or you could use mine. Try 6 on your own, but number 6 goes with the 25%. The lowest 25% would be that, the 51 to the 67.5. the highest 25% would be up, from 88.5 to 100 and so on. Answer those questions. Remember that these are all, each section, there's 4 sections, 25%, 25%, 25%, 25%, when you're answering those number 6. Okay, so back to number 7, something that would be an example of a strong positive. And I thought of the more hours you work and the amount of money that you earn. So the more, obviously, it's going to be strong if you're, at a job, you're getting paid minimum wage, whatever. The more hours you work, the more money you're going to get. It's going to be a very strong correlation. A strong negative would be the farther you drive your car and the amount of gas that you have left in the tank. So it's going to be, it's definitely going to be going down as you drive farther. No correlation would be the age of the students within your Algebra 1 class and their height. You're all pretty close in age, and it's not going to really matter your age, because some people that are 1 year older than the other person are still maybe shorter than those others. So, at this point, that doesn't really matter. There's no real correlation. Remember when you're doing number 8, you're going from the strongest to the weakest. That means the greatest to the least. So it would be 1 to anything between 1 and -1. Okay. That's this way, greatest to least. So, normally, it's least to greatest, like that. Okay, number 8. I'm not sure if you guys are going to get this, but this use of a calculator, if you follow these directions to the T, and you follow these directions to the T, and skip this number 2, you don't need to see it on the graph on your calculator. It doesn't matter. This information is the information that you need to get. So, I don't know if you could zoom in on that, take a picture of it, zoom in on it, and then, read the directions if you don't have it. But I imagine you would. That's how you plug these into your graphing calculator, and then you would get this. And even if you don't have a graphing calculator, you can find them online if you're from home. And just, there's correlation coefficient calculators out there. Just ask you to plug in the data. Just do that and you'll be good. Once you figure out the equation though on your graphing calculator, let me see if it's still on. So here's my list 1 and list 2, and then let me see, calculate, and I think we went down to 4. There we go. So it gave me this is y equals mx plus b, but they use a instead of m, just because, I guess, just because. Okay, we'll just leave it at that. So you plug these numbers in for the a and for the b, and I rounded them to the nearest hundredth. Okay, so that's why mine looks like that. So for this x value, in order to find the expected value, you're going to put this amount in there for the x. So you do 0.33 times 86.25 plus 0.59, and you get this. So the expected value, the expected tip that you would, the expected tip for the bill would be right around $29.05. You also get the R, just the regular, not the R squared, but the regular R is going to be the correlation coefficient on your calculator. That's the R. Okay. And here I just reminded you y equals mx plus b. In your calculator, it's going to look like y equals ax plus b. But this R is 0.8. And a couple problems ago, number 6, you saw that, the closer to 1 you are, the stronger it is. So that is a strong positive there. It's pretty close to 1. There's a pretty strong correlation. Okay, so hopefully this helps, and good luck.